Hello. Now we are going to discuss about serial in parallel out. So data is fed serially, but parallelly we can get the output. So here we'll see that in the less number of the clock pulse, we'll able to get the all output. All data, whatever we are giving input serially, we'll get in the less number of the clock pulse. Whereas we have seen in case of serial in, serial out, we have required if you have 4 bits of the data and we are using 4 flip-flops. So in that case, we have to go for the 8th clock pulse. So at the end of 8th clock pulse only, we are able to get the all the input data as the output. Whereas in case of serial in parallel out, we can reduce the time and in the less interval of time, we'll have output here. So first we'll consider the initial condition. Suppose for example here, we are going to give the input as 1011. Or if you see that in this scenario, whatever condition is being shown here, so in that we have repeated change is there. If initial data is 0, next we have 1, again 0, again 1, again 0. So now here we'll consider the sequence as 1, 0, 1, 0 as the inputs. And here again if you see that clock pulse is applied to the all flip-flops and we are considering positive edge triggers. So whenever transition will takes place from 0 to 1, then flip-flops will be triggered. In the initial condition, when clock pulse is not applied, then output of all flip-flops are 0. Q1, Q2, Q3, Q4. So this one we are considering as like here this is our Q1, this one is the Q2, this one considering as the Q3 and this one as the Q4. So as per diagram we can write here QA, QB, QC, QD also. So now, even now if data is available here, suppose input is 0 is available as per this given stream. This is our LSB bit, this is the MSB bit. So you still will not get any output as per the requirements. So this output is by default 0, it's not our data bits. Now we'll start the operation when positive edge clock pulse is applied. So here if you see that when first clock pulse is applied here, now our LSB bit is available here. So this LSB bit will be available at Q1 since we know that it is the D flip-flop and D flip-flop is the transparent flip-flop. So here this output of Q2 remains 0 as the previous Q3 also, Q4 also. So parallelly here we are able to obtain the output, but all data bits will not get output at the same time. Next, again, if you see that here, we are going to give the inputs. So next input we are during the second clock pulse, if you are going to apply here. So during the second clock pulse, now second bit is available, that is the 1 here. So now output of the Q1 will become 1. At the same time, this Q1 is being shifted here to the Q2. And finally, Q3, Q4 is 0 only. Now again, we'll take the condition of the third clock pulse. So during the third clock pulse here, next data is the 0 here as per this given bit stream we are using. So now this 0 will be available at the output of Q1 and this output of the Q1, what was the previous, it is shifted here to the Q2 and what was the actual data input that is shifted now here to the Q3. And finally Q4 is still 0, that is not our required data. So far we have fed it 3 bits input. Next we are going to see the fourth one, that is the last MSP bit. So that is given here and we are applying the fourth clock pulse. So this rising arrow showed the positive edge trigger. So now this one is available at the Q1. This one is shifted to the Q2, and this Q2 is shifted to the Q3, and Q3 is shifted to the Q4. So now if you see that in this case, so here if you see that in the previous one, we have written wrongly here, data input is 0. So here also we should have 0. So in that case, now this Q2 output, what will be here? 0. So that correction is done here. So finally, whatever data we have given as the input 1010. So this one is our LSB bits and this one is our MSB bits. So what you are seeing that at the end of fourth clock pulse itself, all data inputs what we have given, it is available as the outputs. Like this, we can save the number of clock pulses and at the less time we can get the all outputs. So and here you can see in the diagram also what is the output here. That is the flip-flop output. Same output we are going to obtain here at each and every stage. But at the end of fourth clock pulse only, our all real data which is being fed serially here, that will be available at the output. Thank you. Thank you very much.